So now we're ready to actually make our object move. A few things we'll have to set up before that is, let's make sure that our obstacle has a box collider. Here we'll filter out for a box collider 2D. By adding the box collider, we'll allow this object to interact with other objects with colliders on them, like the player, which we'll add later on. Now let's create a script to make this move across the screen. Inside of our scripts folder, let's create a new C# script, and we're going to call this instant velocity. Then let's open this in MonoDevelop. We'll start out by setting up a property to store the velocity we want this object to have. We'll make this a vector2 and call it velocity. And let's instantiate it as a vector2 that's been zeroed out. Next, we'll need a reference to the rigid body itself. Let's create a property to store the rigid body. We'll type it to rigidBody2D and call it body2D. Next, we'll need to get a reference to the actual rigid body. We'll do this in an awake method. Let's create a void as the return and awake as the actual method. Inside of here, we'll set body to equal getComponent rigidBody2D. Again, when it comes to setting up properties that I want to happen early on in the script's lifecycle, I use the awake method. This way they'd be available after start is called. At this point, we're actually not going to take advantage of the start or update methods, so let's just delete them from our script. What we're going to do is use a special type of update that's reserved specifically for making physics calculations. Let's start off with a return type of void and call this fixedUpdate. FixedUpdate only gets called a limited number of times per frame. This is what also makes it more efficient for doing any of our physics calculations. In this case, let's set the body2D velocity to equal the velocity we set at the top of the script. Now, let's save the script and go back into Unity. From here, we can drag the instant velocity script onto the obstacle instance in our scene. Now let's select the obstacle and go down to the instant velocity component attached to the instance. Here, we'll change the velocity x to -95. Let's save our scene, and now that our instance is moved off screen, we can run this and take a look at how it works. Let's hit play. As you see, the desk will slide across the screen, but you may have noticed that it's just a little bit jittery. One thing we can do is go into the obstacle's rigid body and set its value to interpolate. What this will do is it'll analyze the previous frame's movement and apply it to the current frame. This should help smooth out any jittering we see. Let's rerun this and see if we have an improvement. As you can see, it looks a lot cleaner. Let's stop the scene and apply all of our changes we made to obstacles back to its prefab by scrolling up to the top in the inspector and hitting apply. We'll also save our scene, and next, we'll look into creating a spawner so that we can dynamically create obstacles on the fly.